Assalamualaikum and very good evening. So this week we do lab 5 system response. So for this lab we have two parts, part A and part B. So first we proceed to part A. For part A is first order system. So the first we need to find the transfer function of this system. So I get the answer is 12 over s plus 16. To get the transfer function, we need to enter the value of k and a. And then we use this coding to insert it to MATLAB to get the step response. So this is the coding for part A. So if we run, we get this graph. So we need to find the time constant, rise time, and setting time. So we just right click on the graph and get the time, setting time, rise time, and steady state for time constant. So for rise time, we get this value. This is for setting time and constant time. After that, for part B, is second order system. So first we need to find the transfer function. So for this, I get 1 over RCS squared plus RCS plus 1. So after that, we need to insert the general value to get the natural frequency and damping ratio. To get the value of R, we use this equation, which is R equal to 2 damping ratio L 1 over LC, so 1 over LC. So for condition 1, we use for condition 1, the value of damping ratio is 0. So the value of R will be 0. For condition 2, we get 400 kilo ohm. Condition 3, we get 2 mega. In condition 4, we get 4 mega. After that, we generate the step response. To generate the step response, we use the same coding. For the numerator and denominator, we will refer to this 1 over RCS squared plus RCS plus 1. So the numerator is 1. The denominator for RCS squared is 1. For RCS, it depends on the change of the damping ratio. Which is for the first condition is 0 and plus 1. So for the first condition, we will get this graph. So for the second condition, the value of damping ratio is 0.2. We will get this. For condition 3, the value of damping ratio is 1. We get this graph. And for the fourth condition, the value of the damping ratio is 2. So we get like this. So that's all from me. Thank you.